Good afternoon, everybody. This is your Test 5 review sheet. Your test is going to be on Friday, April 17th. Right now, it is Tuesday, April 14th, so you got plenty of time to utilize this to make sure you prepare yourself for your exam. Now, as far as the circle problems go, I'm not going to give you the exact same type of circle problem on your test, so you need to be familiar with all of your circle rules. This particular problem is saying that chord CD is parallel to diameter AOB. When you have parallel chords, the rule is the arcs between them are congruent. So if AC is 30, then BD must also be 30. It's asking for arc CD. Well, we know when we're doing a circles problem to look for inscribed angles, central angles, and in this case, diameters. And I know the diameter cuts the circle in half, and each half is 180. So 30 plus x plus 30 must equal 180. From there, I solve it, and I get my answer of 120 degrees. Number 2, a little bit of an older one. A right circular cylinder has a volume. I stop in my tracks. Volume equals the area of the base times the height. Length times width, or pi r squared. Does the shape come to a point? Cylinder, no. If it did, it would get 1/3. Cylinder, length times width or pi r squared. It's a circular base, so it gets pi r squared. So my formula is V equals pi r squared times the height. It says the volume's 1,000. It says that the height is 8. And I'm trying to find r. So I do the algebra. I divide by 8 pi. I divide by 8 pi. Those cancel. When you're putting this in, make sure you put it in as alpha y equals enter, or you can put the denominator in parentheses. 1,000 divided by 8 pi is 39.7887 something. From there, I take the square root of both sides. When I do that, I get r equals 6.3. What is an equation of a line? Well, an equation of a line is y equals mx plus b. I need m and I need b. It says that it's perpendicular to this line. Well, the slope of this line is -3. So the slope of a perpendicular line must be the negative reciprocal of that, which is positive 1/3. Remember, perpendicular lines have negative reciprocal slopes. Parallel lines have the same slope. So, now that I have my m, to find my b, I know that x is 3, I know that y is -1, so I substitute the values into y equals mx plus b. You can use a calculator if you're afraid of fractions. 1/3 times 3 is 1, plus b, -1, -1, b equals -2. Now that I have m and b, y equals m is 1/3, x -2. You can also pull up your calculator and you can type it in to make sure it goes to that point. What am I talking about? Well, let's get my calculator up. Is it here? Of course not. Let's find it. Here's my calculator. So if once I know my slope is 1/3, if I just type in y equals second here, if I just type in y equals 1/3 x minus 2, and look at the table, having some difficulties here, and look at the table, I see that this point goes through 3, -1. Okay, so another little trick to see, once you know the slope, this is how much 1 it is. 1/3 x does not go through that point. The lines represented by the equations, well, same type of thing as the last problem. I need to know the slopes. So I have to find the slopes for each of them. Get y by itself. Subtract 1/2 x, subtract 1/2 x. I can't combine unlike terms, so I get -1/2 x plus 4. My second equation, I have 3x plus 6y equals 12. Divide by 6, divide by 6. Make sure you reduce the fraction. -3/6 is -1/2x plus 2. So the slope of this line is -1/2. The slope of this line is -1/2. Parallel lines have the same slope. If they were negative reciprocal, it would be perpendicular. If they were exactly the same, it would be the same line. And if it was neither, it would be nothing. 5, it says that D is the midpoint, and it says that E is the midpoint. It says that AC is 3x minus 15, and it says that DE is 6. Well, what's special when the midpoints are joined? 2 times the midsegment equals the opposite side. So 2 times 6 must equal 3x minus 15. That only holds true when it's the midpoints that are joined. Solve the equation. 3x equals 27. Divide by 3. X is 9. The question is asking for the value of x. Lines J and K intersect at point P, and then it says that line M is drawn so that it is perpendicular to lines J and K at P. These questions, we went over them quite a bit, and I told you that they ask the same questions over and over. I can't really demonstrate this one two-dimensionally, but with J and K intersect at point P, right now I'm taking a third line. You can't see it, but I'm taking a line and passing through here. It's coming out of the board. This line is also perpendicular to the plane that contains them. That's one of those questions you need to just memorize. The other one is when you have two planes that are perpendicular to the same line. Again, it's very hard to draw this, but it would look something like this in 2 dimensions. If 2 planes are perpendicular to the same line, then the planes are parallel. You just need to memorize those questions. They ask the same question literally over and over again. Number 8, you should tell by this picture that this is a hill-SAS problem. It's upside down, but it's a hill. It's a hill-SAS problem. Let's fill in some missing information here. If this whole thing is 16, and this piece is 7, then this missing piece must be 16 minus 7, which is 9. It's asking for BD. Well, hills are SAS. Is there an altitude involved or a leg involved? I see an altitude involved. I don't see a leg involved. Therefore, it's SAS. S over A equals A over S. 9 over X equals X over 7. cross multiply and solve. X squared equals 63. Square root, x equals radical 63. It wants the answer in simplest radical form based on these answers. So I break it down into my perfect squares and my non-perfect squares. 9 times 7, which becomes 3 radical 7. Square ABCD has vertices. Again, it's always easier to put this onto graph paper. You didn't get graph paper on your review sheet, but you have plenty of graph paper, and when you're taking a test, of course, you always have the graph paper to use. A is -2, -3. B is 4, -1. C is 2, 5. D is -4, 3. It's a square, so it's connected. Does it look like a square? It looks pretty damn great. So, it says what is the length of the side of the square? Well, pick a side. I'm going to pick this one. It's asking for the length. Well, you need to know that length is distance. And you need to know the distance formula. Change in x squared plus the change in y squared. I like to count for my change in x and change in y. My change in x, 1, 2, 3, 4, 5, 6. My change in y, 1, 2. 6 squared is 36, 2 squared is 4. D equals radical 40. Again, simplest radical form. Perfect squares, non-perfect squares. 4 and 10, 2 radical 10. A right circular cylinder with a height of 5 has a base with a diameter of 6. Well, let's draw a picture. Why not? It might not help us, but it might help us. Height is 5. Diameter is 6. Find the lateral area. Well, the lateral area is on your reference sheet. L equals 2 pi RH. L equals 2 pi. The radius is not 6, but it is 3. Height is 5. It wants the answer rounded to the nearest hundredth. So you just type this in to your calculator. I'm not going to pull my calculator up for it because it takes me forever to do that. But when I did that, I got 94.247777961. It wants to round to the nearest hundredth. That's 2 decimal places. I look at the next digit. The next digit is higher than 5, so it becomes 0.25. But I'm not done. I'm only up to here. Find the volume. Well, again, volume equals the area of the base times the height, length times width, pi r squared. Again, it's a cylinder, so it's still pi r squared. Substitute the values in. The radius we said was 3, the height we said is 5. Type that in, and we get 141.37166694. Again, it wants me to round to the nearest hundredth. So 1, 2. 141.3. The next digit is not 5 or higher, so it stays 3. Triangle ABC has vertices. A is 5, 1. 1, 2, 3, 4, 5, 1. B is 1, 4. C is 1, 1. It's a triangle, so I'm going to connect them. Looks nice and pretty. State and label the coordinates of triangle A double prime, B double prime, C double prime, the image of triangle ABC, following the composition of functions T, 1, -1, of D of 2. Let's start by listing my original points, A, B, and C. A is 5, 1, B is 1, 4, C is 1, 1. I always start on the right. Dilation, we have our song to help us remember. Dilations multiply. I multiply both coordinates by 2. Now I take those points and do my translation of 1, negative 1. Translations add. 10 plus 1 is 11. 2 plus 1 is 3. 2 plus 1 is 3. 2 plus negative 1 is 1. 8 plus negative 1 is 7. 2 plus negative 1 is 1. It didn't ask me to graph it. I didn't really use the graph paper here because I don't really need it for translations or dilations. Reflections and rotations is really where I use it more. That's it. Write an equation of a circle whose center. Well, the equation of a circle, it always has 2 sets of parentheses. It always has squares. It has a plus between them. We say AB, we generally write the formula as minus. So we write x minus a, y minus b equals r squared, where AB is the center. And r is the radius. So basically you're negating what's in the parentheses. So minus 3 becomes plus 3. Plus 2 becomes minus 2. And the right-hand side is the radius squared. If the diameter is if the diameter is 10, then my radius must be 5. My right-hand side is the radius squared, which means my final answer is x plus 3 squared plus y minus 2 squared equals. I don't need this. Let's get rid of it. In right triangle DEF, let's draw a picture. Angle D is 90, so D goes there. EF. Angle F is 12 degrees less than twice the measure of angle E. Well, this kind of goes back to Algebra 1. D is 90. If it's twice the measure of angle E must be X. Angle F is 12 degrees less than twice that. We're talking about the angles of a triangle. E is F, E is X, F is 2X minus 12. So the angle of a triangle must add to equal 180. That gives me 78 plus 3x equals 180 minus 78 minus 78. 3x equals 102. Divide by 3. Divide by 3. X equals 34. The question's asking me for the measure of angle E. Measure of angle E is X. So the measure of angle E is 34. Again, for the circle problems, it might not be one exactly like this, but you're responsible for knowing all your rules. AE is 2, EB is X plus 3, CE is X plus 1, and ED is X. We're dealing with segments. You have 2 segments rules. You have PP and you have wee. There's nothing exterior here, so I'm not using wee, I'm using PP. So the 2 parts of CD are X and X plus 1. The 2 parts of AB are 2 and X plus 3. Now we do the algebra. Get rid of the parentheses. X squared plus 1x equals 2x plus 6. And I see Mr. X squared. So everybody's got to come over to his house. I get x squared minus 1x minus 6 equals 0. Party time. a party with bubbles, which of course means to factor. First line comes down, negative times a positive is a negative. What multiplies to 6? 1 and 6, 2 and 3. Which pair subtracts to 1? 2 and 3. Bigger number goes first. Set each factor equal to 0. Get some more space here. At x minus 3 equals 0. X plus 2 equals 0. Add 3 to both sides. X equals 3. X equals negative 2. I'm talking about a distance. It can't be negative. So x must equal 3. It's asking for CE. CE is x plus 1. So CE is 3 plus 1. Number 15, do not worry about that. Should not have been its way into the review sheet. I've had to delete it. Do not worry about that. You have not learned it yet. If you're home flipping out about it, it's okay. You do not learn how to do it yet. It will not be in the test. Finally, proof. Yay. Whenever you're proving something, unless it says to prove a specific shape, you're always proving triangles are congruent. Is it obvious which triangles are congruent here? I would say yes. We have that triangle, and we have this triangle. I know to prove triangles are congruent, I prove 3 things are congruent, so that's my goal. And to prove segments or angles, which I have here, I know at the end is going to be CP, CT, C. So I start with my givens. One at a time. I see OG, bisects, angle IGM, given. So I do a mini proof. This is angle bisector. So I write my definition for angle bisector. An angle bisector creates 2 congruent angles. Well, let's see. What's being bisected? IGN. G is the vertex. There's my angle. There are my 2 congruent angles. So G must be in the middle for both of them. Angle IGO is congruent to angle NGO. All right. So with that many proofs, let's move on to the next given. 3. OG is an altitude. That's given. Now I use my definition for altitude. My definition for altitude is an altitude creates congruent right angles. So OG is my altitude. My right angles are here at O. O must be in the middle for both of them. Angle IOG is congruent to angle NOG. All right, 2 things down. What's next? No more givens. When I run out of givens, I use my additional tools. My 2 main ones are reflexive property and vertical angle. There's my reflexive property. OG is congruent to OG. Reflexive property. OG is a volume column quite a bit. Good for OG. I got 3 things. I can see the 3 things in the picture. 1, 2, 3. I can also see the 3 things in my proof. 1, 2, 3. So now that I have my 3 things congruent, I can state that the triangles are congruent. Because remember, that's always my goal when I'm doing a proof. Triangle IOG is congruent to triangle NOG. What's the reason? Well, I see angle, side, angle. And now that I have the triangles are congruent, I can state my segments are congruent. IG is congruent to GN. And the reason, as the song says, is C, B, C, T, C. That's the review sheet, ladies and gentlemen. I hope you enjoyed that. I hope you utilize this. Don't just watch it, but do the problems. If you get stuck, you got the video here to refer back to get unstuck, and keep on practicing them. If you can do them in practice, you can do them during the test. I am going to now stop this recording. I look forward to seeing everybody on Thursday. We will go over this on Thursday in class if you have any questions. Goodbye.